Then you come down here, new string.
So we have our symbols, our math symbols. There are all sorts of operators, but the ones that we're looking at on this screen are the arithmetic operators. Addition, subtraction, multiplication, division, and then two specialty ones. Slash slash. I know I mentioned this last time. He's calling it quotient here. Our other textbooks called it floor division. It just means divide and round down. So 10 slash slash 3 means 10 divided by 3 round down, which is 3. Not 3.333 out forever, which it was what it would be if we did that. Single slash. If you take in Java or another language like that, that is what happens when you divide two ints by each other by default. If you take 10 and you divide it by 3, it's going to equal 3. It's not going to equal 3.333. In those languages, if you had stored 10 into an integer and you had stored 3 into another one and then you did the slash, it would just equal 3, which kind of makes your head scratch. Python doesn't do that, but if you wanted to replicate that behavior, you can force the issue by using double slash to mean divide and round down. And then there's modulus. Percent sign meaning modulus, that's a remainder. If you had 10 modulus 3, well, okay, 10 modulus 4 because that's what I accidentally typed. Then the 4 goes into the 10 twice. So 4 goes into 10 2 times with a remainder of what?
2.
Yeah, with a remainder of 2. And if this was 11 modulus 4, 4 goes into 11 2 times with a remainder of 3. And then if it was 12 modulus 4, 4 goes into 12 3 times with no remainder. It's evenly divided.
So what would the answer be at that point?
0.
Oh, it would be 0?
Yep. 0. 0 is a perfectly acceptable mathematical result of doing divisions. If you divide 4 by 2, there's no remainder. So yeah, its modulus would be 0. So these are all, except for the very specific example of sticking a minus sign in front of a number, what are known as binary operators. Binary operators meaning they need two pieces of data upon which to work. You can't multiply unless you have two numbers to multiply together. You can't add unless you have two numbers to add together, and so on. So the operator is the symbol, and then the operands are the values, one on each side of the operator. So precedence rules. If you remember the phrase PEMDAS from your grade schooling, that stands for the order of operations. Parentheses are done first, then exponents, and then multiplication and division have equal priority, and then addition and subtraction have equal priority. But why don't we go ahead and make our lecture document so that we can take some notes. I believe we're on E. Hope so, because that's the name of the folder I created. First upload into. No, we're on F. All right. Then wait a minute.
You created that.
You made it.
I made it F? Okay, yay. All right, see, I was trying to work ahead. Okay, so lecture F. I want to finish chapter 2 by today, gum by gum. So I'm not letting y'all out until we're done. Doesn't matter if it takes 5 hours. I'm kidding. That's not going to be the case, but we ought to be able to do it. Okay, so we have our operators. I'm going to just start some quotes with a triple quote. You know, addition, subtraction, multiplication, division, and then floor division, which is slash slash, and modulus. Dat slash slash is floor division. Textbook called it quotient. Divide and round down. Drop the fractional part. And percent sign is modulus, which means remainder. Order of operations. Operator precedence. PMDAS, where the P stands for parentheses. E, wait, I forgot. E, there we go. E stands for exponent, which is star star. Oh, and I forgot star star as being one of my math operators up here. So I'm going to tack it on there, and I'm going to mention it here. Star star means exponent.
So if you're doing a script to, if it asks you to make a calculation and only use like 2 decimals, like 2 spaces after a decimal, which one of those would you use?
None of these will do that. Very good question. Now, what if the output said display only 2 decimal places?
Yeah.
There's a couple of things you can do there. And if you're thinking about the homework assignment where I said display only 2 decimal places, then that's a matter of modifying your output so that the calculation may have 1,000,000 decimal places, but we only want to display 2 of them. But you can also round your data in such a way as that it really only is accurate out to 2 places. Let's get there in just a second. Thank you for mentioning that. Okay, so PEMDAS, please excuse my dear Aunt Sally. Anyways, M and D stands for multiplication and division. However, in this language we have other forms of multiplication and division as well. Modulus is a form of division. Floor division is a form of division. So those are all equivalent in the same priority level. So multiplication and division, floor division, and modulus are all of the same priority. And then lastly, addition and subtraction. So if you have something like this, 2 plus 3 star star, 3 star star 2 minus 1 times 2 divided by 3. I'm just making that up, and I'm probably going to regret it. I think I'm going to take the divide by 3 off. So if we look at this, there's no parentheses, so we don't have to worry about that. There is an exponent, so that would be the first thing that the computer would evaluate in that expression. And 3 to star star 2 means 3 to the power of 2. 3 squared, 3 times 3 is 9. So that part of it's going to be 9. If I rewrote it, kind of like the way the computer's thinking about it, then at this point, after step 1, that's what the computer's done to it. Now, then it's going to go and it's going to do all the multiplication and division. And it doesn't mean do all the multiplications first and then do all the divisions. It just means go left to right, and if you find any multiplies, do it. If you find any divides, do it. Well, we don't have any divides, but we do have a multiplication. 2 plus 9 minus, okay, there's our multiplication. So what's 1 times 2? 2. So now the computer thinks of it like this. It's done with that tier of operation. It's done with that priority. So it's going to do addition and subtraction. And again, it doesn't mean do all the additions first and then come back and do all the subtraction. It just means go left to right, doing them in the order in which you find them, which in this case does happen to be A and S. Right, but 2 plus 9 is 11, minus 2 is back to 9, and so 9 is our answer. So this was our expression. These were the intermediate steps taken to get to that answer. Now, I'm never going to ask you to write it out log form like that, right? But I might ask you on an exam to calculate in your head the result of this expression, right? 3 minus 2 star star 2 plus 4, whatever, right? And so what would you do first?
Exponent.
Exponent, so 2 star star 2, that's 2 squared, that's 4. And then you would, there's no multiplications, there's nothing else, there is addition and subtraction, so left to right, 3 minus 4 plus 4. Well, that's just 3. And you can use the parentheses to change the order of evaluation. If we had this expression here and we wanted something to be done first, like if we had that expression but then we did this, just means do that first. Then things start looking a little bit different. 2 plus 3, that's the parentheses. It gets done first. So that's 5 star star 2 minus 1
25.
times 2. So 5 star star 2 is 5 squared. 5 times 5 is 25 minus 1 times 2, which is 25 minus 2, which is 23. Again, that's long form. You ought to be able to look in your head or with a piece of paper, kind of figure out what would happen here. Now try not to make them so hard you couldn't do them, in your head. You just go, oh, that's parentheses, I better do that first. 5 star star 2 is 5 squared, that's 25 minus 2, and that gets you your answer. With two exceptions, operations of equal precedence are left associative, so they're evaluated left to right. Just like I was saying, if you have addition and subtractions in the equation, you just go left to right, finding all the additions and all the subtractions and doing them. That's called left associative. They go left to right. The only difference is star star is right associative. Now, honestly, I'd never even really thought about that before I looked at this page, but if you have this expression, 2 star star 3 star star 2, what does that mean? Well, it's right associative, so it does this part first in its memory. And then the 3 star star 2 is 3 squared is 9, and then it takes 2 to the power of 9. Let's see if that's true. Let's see if that actually works out. If I go into the shell, run the Python shell, and I type in 2 star star 3 star star 2. Is that the same as 2 star star 9? Yeah, it is. Okay, so it did this part first, and then it did this part first. But star star is really the only thing that works like that. It also mentions the equal sign working the same way. Yeah, I don't even really know why I would care to talk about that, but if we had this, and then we said A equals B equals C equals 7, that copies 7 into C, and then copies it into B, and then copies it into A. So again, it's right associative, meaning right to left. Right. The 7 goes into the C, goes into the B, goes into the A. Just like exponent-wise, this one was done first before that. Now, do I see a lot of expressions where you do that? No. If I was worried and wanted to make absolutely clear what happened first and what happened second, I would use good old parentheses. You can never go wrong by adding parentheses, even if you technically didn't need them. That's a lot clearer, right? If I gave you that, you would know instantly, without having to have any clever programming knowledge, that this part would get done first before that. So when both operands of an expression are of the same numeric type, the resulting value is also of that type. And this is a big fat lie. This is such a huge lie. I need to just correct this and re-upload it because I don't know what the author, what kind of cough syrup they were on when they wrote this slide. But do you remember when I was saying in languages like in Java and in C, if you divide an integer by an integer, the result is an integer, and so it will round down? But it's not true in Python. I don't know if the person just cut and pasted this from a different textbook's PowerPoints or not. This is, there we go. Okay, really, I do need to take that slide out. So why don't I just try to make a point of doing that? Delete it right now and re-upload it. So mixed mode arithmetic involves both integers and floating point numbers. You must use a type conversion function when working with input of numbers. It is a function with the same name as the data type to which it converts. You need to convert a string to a string to a float. You do something like this, d equals float d. And that would turn whatever was inside this string, or whatever it is, it could be an integer, and turn it into a floating point number. Or you could do I is equal to int I, and it would take whatever had been stored in I, convert it into a whole number, and then store it back into I. And so the input function, since it always returns a string as a value, you have to use int or float to get it to be numbered before you can do math on it. All right. Say we had that number and we wanted to print it, and we wanted to print it really nicely and make sure that it was displayed to 2 decimal places. It is 2 decimal places right now. But what if, due to some rounding error, the computer calculated our profit as being that, and we did not want to tell the user that they had earned $1,000 and 55,000,011 cents, right? So we need to learn how to format our output. There's a couple of things you can do. What if we have this number here? I'm going to end my comment so that I can actually start typing in some code. So I'm going to put my triple quotes here so that the next thing I type is not a quote. Profit equals 1000.55. There. I just added on a whole bunch of digits. I don't care what digit you add. Just make sure that there's more than 2 numbers after the decimal place. Right? They could be all 1s. They could be all 9s. I don't care. Just make sure you got some numbers there. But you want to print it out. Print, parentheses, quote, profit equals. Here's what we would have been doing up until now. End quote, comma, profit. And now when we run it, it's going to say that. But I wanted it rounded to 2 decimal places, or 1 decimal place, or 3, or something like that. I keep using the word round because rounding is one way to fix it. We could do this. I'm going to make a new variable. I don't know why. NP for new profit, not sure, is equal to the rounded version, round, parentheses, profit, in parentheses. And now let's print that. Print, parentheses, quote, NP equals, end quote, comma, NP. So it's not going to print out 100.55 whatever, it's just, or 1000 dot whatever, it's just going to print out 1000, because what does round do? It rounded it. There we go. Rounded it. That's kind of true, right? If you take 1000.55, you might say I made about $1,001. But what if I didn't want to round it? What if I wanted to round it to dollars and cents? So I needed it rounded to 2 decimal places. After the word profit here, but before the closing of the parentheses, put a comma 2 there. Rounds to 2 decimal places. A lot better. So does that solve all of our problems? We can always just round something to 2 decimal places and display it. Well, it does stop the problem of having too many decimal places if we're trying to print out dollars and cents. But what if it was all zeros, right? Like that. Then it said 100.0. That's okay, but I might want to see the .00 like we're used to seeing on our cash registers. It's how we think about money. I'm going to go ahead and make this have some decimal places again. Now here's what you would really want to do. I'm going to go back to printing out the word profit. the variable profit rather than NP, because this is an acceptable fix, right? It does round it to 2 decimal places, but I may not actually want to round my data. I may just want to change how it is displayed, right? I might be really miffed if I did not earn my 0.00656423, cents of a profit. So anyways, print, parentheses, quote, profit equals, and I'm not going to do an end quote here. Instead, I'm going to use a percent sign. Percent dot to F, end quote. This is a placeholder that's going to be filled in by a variable, and what it's saying is that the number that's coming up is floating point, it's got a decimal, and I want you to round it to 2 decimal places. So the percent sign means this is a placeholder, and then the rest of this stuff controls how the data is formatted. So this is a control code. So we have this data, but we need to pass in, we have this placeholder, but we need to give it a value. Okay, just for giggles, we're going to fix this in a minute. But type in 6.12345 there. And if you've done Java programming or C programming, you may have heard the word printf. That's what this is doing. It's doing a printf, a formatted print. So now when it runs, it's going to print that 6.12345, but right? Just to 2 decimal places. What if I wanted more than 2? What if I wanted 3? I can do that. All right, now it's 6.123. What if I don't like decimal places? What if I don't want any? I could put a 0 there. And then it just says profit is equal to 6. Okay. But are we going to print out a number? No, we're going to print out a variable. So I'm going to go ahead and put the word profit there. And since I want it to be dollars and cents, I'm going to put that back to being 0.2. And so when it runs, it shows a profit of 1,000.55. And it does so without actually changing the data, right? When we did this business of rounding it, our variable now had something different in it, right? So we lost some data by rounding it down, and that was fine if that's all you really want to do. But if you're going to keep using this value for further calculations, you probably don't want to round it. Instead, you just want to control how it is displayed. I don't want my bank account rounding down my dollars. That's a plot to some movies, isn't it? Like Office Space and Superman, the one with Richard Pryor, and if you can think that far back, where they write programs so that it rounds down to the nearest cent, and then all those extra fractional cents are deposited into the hacker's account, and they earn millions of dollars that way. Anyways, this is how the homework that asks you to calculate interest. This is how you could force it to display 2 decimal places. There is another way of doing it as well. There's another syntax for doing it, and I really don't remember which way this textbook does it. This is slightly old school, using this percent sign to do your formatting. You will notice that just about any time you type in a question about programming, the answer is at Stack Overflow. They've become amazingly popular over the past 10 years. They're an incredible site. Okay, here's what a placeholder looks like if you use the so-called new style of doing it. I'm not going to even do the new style. That's actually more complicated. Well, it's more complicated because I'm a little less familiar with it. But you see here, this guy asked how to round down his output to 2 decimal places, and one of the answers does exactly what we're doing here. %.2f. Then for some reason he goes ahead and rounds it to 2 places with that command as well, but that wasn't necessary. He could have just put %.2f and then %a. That would have worked just fine. But there's an alternate syntax, which I guess we may as well cover, just for thoroughness sake. And then print, parentheses, quote, profit equals curly brace. Let me make sure I get it exactly right. Curly brace 0:.2f end curly. Curly brace 0:.2f end curly brace end quote dot format parentheses profit in parentheses in parentheses. So the first way is old school. The second one was introduced with the newest version of Python. Well, not the newest version, right? But there's Python like 2, and then there's Python 3. This was introduced in Python 3. This kind of looks like how you would do it in C#. If you ever use C#, then the syntax will look very similar. What does this 0 here mean? It means the first thing in the format string. Basically, my big takeaway just from looking at it at this second is that this is easier to type. So, but this is an alternate way of doing it. I'm just going to put alternate syntax, which is worth covering at a future point. The reason I'm mentioning it now is if you Google up how to format Python output, it may show you this method. And so I want you to know that it exists, but there's 2 different ways. There's using the % to format your output, where the placeholder is declared with a %. And then there's this curly brace where you follow it with the dot format function method. All right, so what if I wanted a $, right? I like $signs. When I run it, it'd be kind of neat and nifty if it said, you know, profit equals 1,000, or, you know, $1,000. Well, that's easy. I just need to add a $. Where would I add a $sign to this to make it look pretty? Yeah, right before the %. Yeah, that would do it. And I could also, you know, put a $sign there on the dot format method as well. So I'm going to be using this %.2f business a lot just to kind of hammer it into your brain. Because whenever you print a floating point number, you probably don't want to see 90 decimals, you know, places after the decimal in your output. The user doesn't want to know that if you convert Celsius to Fahrenheit, that it's now equal to 75.231111111 degrees. Instead, they just want to see, you know, a reasonable, you know, number of decimal places. So please memorize that %.2f will display to 2 decimal places, 2 places after the decimal points. And 3 means 3 decimal places, and 1 means 1, and so on. So functions and modules. Python includes many useful functions which are organized into libraries. There are graphics modules. There are statistics modules. You know, there are all sorts of modules. What is a function? It's a chunk of code that can be called by name to perform a task. We have already written a couple of functions in here. Not very many, but I definitely remember doing a def main one day. And we put all of our code inside of a main function. We don't have to put all your code in a main function, although it's actually good programming to do so. But it will become very useful for us to write our own functions. If there is a function already provided, called a built-in function, in some book that I used at one time called them BIF. I love that. BIF. Built-in function. Okay, I'm never going to say the word BIF again for the duration of this class. But a built-in function is one like int parentheses, or print parentheses, or input parentheses, or float parentheses. All those things that we've been using in our code. We don't have very many examples, but there's one. There's one. All those things that show up in purple. If you need to find out more information about a function, you don't have to go to Stack Overflow. Just go to Python shell and type help space round. Ooh, that's not right. Help parentheses round in parentheses. And here's what it does. It rounds a number to a given precision in decimal digits. So if you pass in round and give it a number, it'll round that to a whole number. But you can also specify a number of digits. The return value is an integer if in digits is omitted. It's kind of talking, programmerese, getting a little bit, technical here, but it's giving us useful information about the round function. In digits may be negative. Okay, now that's crazy. I never thought about the fact that you could take a number and round it to a negative number of digits. What if we had the number 6.54321 rounded to -2 digits? What does that even mean?
Does it have to be bigger than 2 digits?
Maybe that's it.
1,000?
Yeah. So it's like rounding it to the tens place, at a hundreds place, at a thousands place. If you pass in -1, it means rounded to 10, right? -2 means rounded to 100. 5 would mean to the nearest 10,000, right? Learned something new. See, I'm glad I did help round. Help parentheses print. Lots of information about the print function. Help parentheses input in parentheses, and so on. When you write your own functions, you can provide what's known as a docstring, so that if you typed in help and then gave it your own function name, it would be just as helpful, displaying all that information as it is for these built-in functions. So let's define a function. Let's define a function that's going to take a number and print it out in this fancy format, like that. So define display underscore profit, parentheses P for profit, in parentheses colon. Let's put some print statements. Print. Get ready. Here comes the profit. Exclamation mark, end quote, in parentheses. And then print parentheses quote, profit equals. Do we like dollar signs? Yes, we do. So $, %.2f, end quote, %p. And you can put spaces there if you want, in parentheses. And then you can tack on the word return, which means bail out of that function. Okay, I wrote some code. It looks pretty awesome. I'm ready to see the words, get ready, here comes the profit. When I run it, I'm not going to see that happen. Did not do that. That's because we defined a function, but we never actually called it. It's like me writing a recipe, but if I don't, actually give the recipe to somebody to cook, then the cake doesn't get made. So display underscore profit, parentheses 3. That would call the function. Display underscore profit, passing in our profit variable, parentheses profit. Display underscore profit, 3 * 10. We have a lot of profit that day. 3 to the power of 10. And so on. Each one of these is going to call this function and rerun it. So these 2 lines of code are going to get executed 6 times. It's going to get executed with 3. It's going to get executed with that variable, profit, being passed in. And it's going to be executed 2 more times with whatever 3 to the power of 10 is. And we see that it did in fact do that, right? We see it was invoked 3 times. Yep. Profit was $3 the first time. It was $1,055 the second, because we actually passed in that variable we had been playing with earlier. And then it was 3 to the power of 10, which is apparently 59,000. In this language, you can define your functions just right anywhere. It's not a big deal to go ahead and just write a function right then and there and then immediately call it. Typically what people like to do is they like to define all their functions and put them up at the top of the file. So I should cut and paste that and move it up to the top. But in this language, you don't have to. It's okay to leave it like that. Let's write another function that'll add 2 numbers together and return the result. So the magic word is def. Our function is going to be called add. We want it to be able to add 2 numbers, like maybe x and y. So x, comma, y, in parentheses, colon. So we're going to calculate the result. Result equals x asterisk y, return result. Now again, it doesn't do anything. We've defined it. We wrote the recipe. But until we actually call the function, nothing happens. So like if we do this, print, parentheses, add, parentheses, 10, comma 20, close parentheses, it's going to print 30. Because add 10, comma 20 invokes the add function. 10 gets copied into x, 20 gets copied into y. Okay. This is dumb. I'm dissatisfied with my code. Can you guess why?
It's all but one.
Yeah, why did I put an asterisk there if it's supposed to be adding? Why don't I change that to a plus? There we go. All right, now it would print 30 rather than 200, which is what it was just about to print. There. So we could do something like this. You know, I equals add 1, comma 2. J equals add I, comma I, right? Whatever. Each time we use the add word, it invokes the add function, passes the values between the parentheses. These are technically known as arguments. So add is the function. 1 and 2 are the arguments. When we're creating the function, right here, when we're defining it, add is the function, x and y are the parameters, or you can call them parameter variables. I prefer that term, but a lot of books have gone to just calling them parameters. The arguments get copied in to fill the parameters. So when we call add, parentheses 1, comma 2, 1 gets copied into x. So we now have a variable named x. 2 gets copied into y, so we now have a value for a variable y, and we can use those variables in order to do something. So functions are coded into components called modules. The built-in functions like ABS, meaning absolute value, and round, are always available. However, the math module gives us other functions. So you can include that module, and then you can use the things that are in it. So for example, if I know I need the ability to use pi, import space math.
Could you just do import pi from math rather than just...
I could import pi from math. You're correct. I'm going to do it this way first. Then, the area is equal to pi r squared. So math dot pi times, I don't have a radius yet. Forget it. Come back. So x equals math.pi. And we could print x out or do some math with it or whatever we wanted to. There are other functions in the math library as well. Why don't we Google up Python math module? .ceil, which stands for ceiling. Ceiling is like rounding, except it rounds up rather than it rounds down. So the ceiling of 1.001 is 2. The absolute value of x, fabs. I'd be curious to know what the difference between the absolute value that's built in and then calling fabs. And then there's one for factorial, there's one for floor, and so on. Well, let's do some things. You know, y is equal to the floor, math.floor of 1.1, and that's just like rounding down. So the result will be 1. Floor rounds down. And then z is equal to math.ceil 1.1. Result will be 2. Ceiling rounds up. If you've ever done Excel macros, you may have gotten used to those things. What if you hate prefixing the word math in front of everything you type? You don't want to have to type in math.floor or math.ceil. You just wish that you could use the word floor, right? Or that you could use pi without using math in front of it. Just like you said, we could do this. From math, import pi. From math, import floor. From math, import CEIL. Then we could just do x is equal to pi. Y is equal to the floor value of 1.1. And z is equal to the ceiling of 1.1. This gives you very fine-tooth control about what you're bringing in. What if you like being able to do this and leaving off the math dot, but you don't like having to specify each one of them in turn? There's a syntax for bringing them all in. From math, import asterisk. The asterisk meaning everything. And now we could use everything in the math module without using its prefix. Now, honestly, I think the prefix is useful information. Half the time, I'd rather actually just do import math and then use math dot in front of all the functions inside it. Because otherwise, when I'm looking at the code, I may not remember where floor comes from or where ceil comes from. You know, I don't, and then, you know, I'd have to go and figure out, oh, that was something in the math function, in the math module. Let's go, and since we have now done this, let's find one more module to call GCD, greatest common divisor. That's wild. Logarithms. A equals log 2 of 10. I don't even really quite remember what that does. But, right, if we had not done this from math import star, we would have had to have typed in math.log2. Or we could have gone up here and done from math import log2. But since we did from math import star, this brings in everything in the math module. But you got to pick one or the other. I mean, I guess you don't have to. But if you do from math import asterisk, you're not going to then be saying math.pi, math.floor, math.ceil.
You just type in your formula and then it'll do the rest.
Right. Now, if you really, really, really want to be, and I have done this at a certain time in a very specific thing, you could do, don't type this because I'm going to immediately delete it. like say you had import math and then from math import star. That would give you total flexibility as to whether you're going to use math dot in front of the function names or not. Delete that. So you can avoid the use of the qualifier. That math dot is known as the qualifier by importing individual resources. From math, I want you to import PI and SQRT. That's pretty cool. You can do more than one of them at the same time. I was doing them at one at a time. If you felt like it, from math, import SQRT, comma, log 10. Right? SQRT being square root, of course. B equals SQRT of 100. Square root of 100 is a 10, so if I printed B out, it should say 10. So this is talking about writing a main module. It's not really explaining why you would want to do that. That's almost a bigger lecture than I want to give at this point. But it is good programming practice to take all of your code and put it into a main module.
Does that give it more precedent than the rest of the code that you put underneath?
It's not that it gives it more precedence. It allows your module, your code, to be imported into somebody else's code with an import statement. You know what? If we're at the end of the chapter, which I think we really are, then we could actually do that part of the lecture. So, program format and structure. Start a comment with the name, the purpose of the program, and other relevant information. Put that in a so-called docstring. In other words, do the 3 quote thing. Then include statements that import the modules, that initialize important variables, that prompt the user for input, that processes the inputs and displays the results. Okay. And a chapter summary. Okay, so yeah, we're going to talk about why you want to put things inside a main module. But I don't want to cut and copy and paste and change these notes to have that. So I'm going to create a brand new one called Lecture F2. So Lecture F2. Now, what is this going to do? It's going to ask for 2 numbers and then multiply them together. X equals float, parentheses, input, parentheses, quote, enter a number, end quote, in parentheses, in parentheses. Then just copy and paste that and make it say enter another number. Make it y is equal to float input, enter another number. And then let's calculate the product. P equals x asterisk y. And let's print the result. Print, parentheses, quote, the product of those numbers is, end quote, comma, P. Now I'm going to save this, and I need to save it into the same directory for this lecture to work as the other one. So save as, I'm going to call it Lecture F2. Now, if this code, if we needed to run this from within our other code for some reason, if after we calculated the square root and everything, if we added this, import F2, excuse me, import lecture F2. It's going to run the code. It's going to immediately do that, and that. Just by importing it, it's going to trigger and do all of these statements. You don't typically want an import statement to start suddenly doing stuff. Right? Importing should just make it available to you. It's like getting out the dictionary so that you can use it. You don't want the mere act of getting the dictionary out cause a whole bunch of things to start happening. The mere fact that we are importing this module does not mean that we actually want to start doing all that stuff. But it's gonna. Or I could get an error. Is it lowercase pi? Yeah. All right, everywhere I've used pi, and I used it in a whole bunch of places, make it lowercase pi. Looks like I used it in 3 places. All right, and see, enter a number, enter another number. The product of those numbers is 24. Okay, great, but it's really poor form to write code that triggers as soon as it is imported. It's like writing a book that starts doing something as soon as you pick it up. Shouldn't do anything until you actually turn to a page and start reading it. The code should not actually be triggered until a function is called. Well, the problem is we don't have a function. We just put all of our code straight, unindented. So I'm going to turn this into a main function. So def space main parentheses in parentheses colon. And then tab these 3 guys, or 4 statements. Control S to save that one, and then come back over to the other one and run it. And good, it didn't start asking me for, a number and another number. Not until I actually add this line of code here. If I go and put in main parentheses in parentheses there, now it's actually going to do this stuff. Or not. I made a mistake. It should be lecture f2.main because that's the name of the module. If I had done from lecture f2 import main, then I would not have to have prefixed it with that qualifier. All right. Awesome possum. I can import it without it running, and then when I finally am able to run it, I can call it as many times as I want to. That would get tedious, right? Having to enter a number and a second number over and over and over, but we can, right? It is well behaved. Maybe it's not perfect though. And why do I say that? I've now made a program over here that doesn't do anything. If I come up to the top of lecture F2 and do run module, it doesn't do anything. Well, it did something. It defined a module, but like I said, defining a module, it defined a function, but if you don't call a function, nothing happens. Now, I could call it right from the shell, right? Normally, you're not going to want to do that. So after you stick all your code in a main function, you will then need to call it like that. By the way, I'm going to wind up deleting these 3 lines of code to prove a point in just a second. But first, to show that this actually works, there we go. It's working good now. Right? I have some code here. And then if this is so useful that I'd ever want to import it into another piece of code, I could. Okay, but here's the problem. And this is where it's going to get a little bit weird. But I'm actually going to start making us type this in every single lecture that we begin. Did you see what happened? It's now auto running again. Right? I deleted the calls to main, but the mere act of importing it is causing it to do that enter a number, enter another number business again. Why? Because it has this main call right here. So as soon as it imports it, it brings all that code in and it runs it. So here's what you're supposed to do, and it looks ugly. We're supposed to close the call to the main function in a funny looking if statement. And the syntax for this is very particular and easy to get wrong. So I'm not going to expect y'all to start doing it yet unless you just feel like it. We're going to start demonstrating it, though, over and over in our lectures until it becomes second nature. If underscore underscore, two underscores, name, two more underscores, equals equals, quote, main, whoops, I forgot my underscores. See, I told you the syntax is arcane. Quote, two more underscores, main, underscore, underscore, end quote, colon, main parentheses in parentheses, like that. Now we have our code ideal, and these are double underscores. These are pairs of underscores. We have 8 total in this expression here. Now we have the ideal situation as to where we can run that program just by opening the file and running it. Works great. But if I import it, it doesn't run. Right? It didn't ask me to enter a number, enter a second number. It doesn't run until I actually do this. And what did I do wrong? It's the same mistake I made as before. Somebody tell me what I'm going to have to do to fix it where it says main is not defined because of the way I called it here.
Main is?
I need to prefix it with the name of the module. Lecture F2 dot main. Okay, if that's not totally sinking in yet, that's okay. What we have done here is we have put all of our code in our program inside a main method so that if we ever wanted to import it into another code, it would not automatically run. Instead, it would just define everything and wait to be run. But then that introduced the problem that the code just doesn't run. You know, if you edit it and click the run button, you know, or hit F5, it doesn't execute. So then we tacked on this code. And I'm not going to explain at this point in time what this is actually doing. But this statement is only true. This if statement is only true if you're actually inside the code when you run it. If I come over here and I do run module, then that statement is true. And so it goes ahead and calls the main function. But when it is imported, when it imports it, this thing is not true. And so it doesn't call the main function unless we specifically add that call. Other programming languages, some of them require you to put everything inside of a main function or a main method. C++ and C and C# and Java, for example, require you to put everything inside a main function. It's just a good habit to get into anyways. It makes your code look way more professional. But on the other hand, we see that, you know, we've only done this a couple of times. You can certainly write code without doing it that way as well. But just to get used to the idea, I'm going to do it that way, probably from now on. And there's one more reason to do it that way, which is that, now I'm not going to mention why. All right, I've gone a long time without asking if people had syntax errors. So why don't I pause it and then, yeah, I figured. The fall. So the problems I'm seeing are if we had saved this as a name with a space, there may be a way to fix it, but there's a problem. This space here is going to mess everything up. I can't just edit the spaces out here and then have it work with the space in the file name. Another problem is if there isn't like lecture F.2. That makes sense, right? It's the second lecture, right? Second file in the lecture. Our file names, technically from now on, should not have any spaces and any extra dots in them, only one dot. And we hadn't even really mentioned that in the past. So if you're having problems, it's not running, it's saying it cannot find module or something like that, just do a save as and call it lecture F2. Exactly, no spaces, no extra dots, anything like that. And if it doesn't work, I mean, for you guys who are watching at home, it's okay. You've gotten the idea, even if you didn't totally get it to work. I never demand that you make your notes perfect before you upload them. If you get at the end, I don't want you to spend 2 hours trying to figure out why it's not compiling. Just upload it. You know. Not true for homework. I want your homework to work. Well, here's the homework assignment. Let's edit it just a little so that statement 6 is not missing a line. You know how to do all of these things, but in case you don't remember, add, multiply, divide, subtract, those are the symbols for them. Floor division, and to the power of. I left off modulus. If you feel like doing another one, print the power, print the result of x modulus y, feel free to tack that on. And then upload the Pi script and a screenshot of it running. But this is no longer homework 1. This is homework, I believe, 5. Yep. All right, there's a Dropbox for Lecture F. Go ahead. You can put both of your files in there if you want. The big one, the one that we did most of the typing on, right? That'd probably be the most important one to upload, but if you feel like putting both of them in there, great. Since it has that if syntax at the bottom, it'd be worth keeping. So I'd go ahead and upload them both.